Okay, good morning, good afternoon, and good evening, depending on where you are, and a very happy Friday to all of you. It's my pleasure to welcome you to this webinar from GitaCloud and SAP. My name is Günther Schmidt, and I'm a principal with GitaCloud, and I will be your moderator. We have a great turnout today from around the globe and some very interesting material to share. I'm actually personally quite excited about the capabilities we're about to see, as they will help greatly at every single company I worked for over the past 20-something years. What I would like for you to do as you're watching, think about the effort and elapsed time it takes your business teams and IT teams to support today in your current system environment. Okay, today's topic is order-based supply planning with SAP IBP. This is a continuation of our 2017 webinar where we focused on time series supply heuristic and optimization to support S&OP processes. This webinar is brought to you by GitaCloud and SAP. At GitaCloud, we are very passionate about enabling digital supply chains. Order-based planning is a key capability to deal with short-term volatility both on the demand and supply side on the quest to deliver the highest customer satisfaction. And we are pleased to be at the leading edge, delivering training and enabling this capability for our customers. Few housekeeping items before we jump in. All attendee microphones will stay muted for the entire webinar. This webinar is being recorded, and we will send you the link for the recording afterwards. Please submit your questions anytime during the webinar. You can use the GoToWebinar chat section to ask questions, and the team will try to answer them right away. We will then consolidate and attempt to answer any remaining questions towards the end. And we will follow up one-on-one if there's any questions that we couldn't cover here. Lastly, please complete the exit survey, which should automatically pop up when you're exiting the GoToMeeting session. Now, let me quickly introduce the panelists for today's webinar. Ashutosh Bansal is the President and CEO of GitaCloud. Ashutosh has 25 plus years of SAP supply chain solution experience across SAP ERP, APO, and now IBP. He was at SAP for 10 years, where he played a key role since the early days of SAP integrated business planning. Since starting GitaCloud in 2015, Ashutosh has led several IBP sales and delivery engagements across the globe. Ashutosh blogs actively and has more than 10,000 followers on LinkedIn. Eric Simonson is a director in the SCM Solution Management team at SAP America. Eric is the solution owner for IBP Response and Supply. He has more than 25 years in supply chain planning and was heavily involved in anything from forecasting to supply planning to production scheduling. Deep Chichia is an IBP consultant with GitaCloud. Deep led an IBP S&OP implementation at a CPG company last year and is currently helping them to extend the footprint to demand CPIDS-based integration with a non-SAP ERP system and other IBP applications down the line. Earlier, Deep led an IBP pilot to deliver forecast error reduction by around 60% for another large CPG company. He also delivered proof of concept engagements for large customers in CPG and pharma and has led several customer workshops across IBP S&OP, demand, inventory, and response and supply applications. Deep is a hands-on expert in order-based planning and SDI integration, and I believe IBP is his middle name. Okay, let me quickly walk you through the agenda for the webinar so you understand how we're planning to spend the next 90 minutes. We will next go to Eric, who will provide a 15-minute overview of SAP IBP order-based planning processes. Deep will then take you through a deep dive showcase of IBP order-based planning capabilities based on the latest release 1802 for about 50 minutes. Eric will then come back to cover the IBP order-based planning roadmap over the next 3 releases, IBP 1805, 1808, and 1811. Then Ashutosh will cover the GitaCloud events calendar and talk about how customers and practitioners can ramp up on IBP order-based planning. We will then open the floor for Q&A. We have almost 500 registrants for the webinar, so we will try and answer as many questions as we can. Without further ado, let me pass the baton to Eric for him to take you through the IBP order-based planning overview.
Excellent, great. So I'm going to start off with the most famous IBP slide that most of you have probably seen over the years, and that is the components that make up the IBP platform. So for today's conversation, as Gunther had mentioned, we're going to focus our energies on the bottom here for IBP for response and supply. And in 2017, there was a webinar about the tactical supply planning. So today we're going to focus our energies on what we call operational or order-based supply planning. Right. So let's talk about the problems that we're solving. What are we trying to address with this, right? So we're talking a little bit in a shorter term horizon. So it's not necessarily something that's tactical in the rough cut capacity perspective, although we could run this out for a further horizon. But we're really trying to do this to try get a hold on and a grip on volatile demand that's happening. We know that there's product life cycles that are shorter these days. We know that customers have lots of choices. There's a proliferation of product availabilities. So this is an application that's going to be able to do our supply planning, if you will, and then also be able to respond to some of these short-term disruptions or changes in the network. So since we know that demand is usually highly volatile in the shorter term, right, we can typically predict in the future what our demand might be at a certain aggregate level, but as we get closer to today and the level of granularity gets lower, those things become much more variable. So we have to be able to react or respond to that quicker. So with that, inventory can be a buffer of this. And for those of you that's worked with IBP for inventory, we know that's fix the mix. We want to make sure that we get our inventory level set correctly. And that's an input to this process, right? It's one of the really key inputs to our operational supply planning, as well as the demand forecast from IBP for demand and or existing sales orders, right? So we have consumption techniques, et cetera, to be able to take that into consideration when we're determining our supply plan. So we know that the world's not perfect, right? If everybody could forecast 100%, we wouldn't really need all these special fancy tools and algorithms and et cetera, but that's just not the case. So I'm going to take you through here the next kind of just an overview, and then I'm going to get a little bit deeper into some of the specifics in terms of the data flow and some of the algorithm. So what is this algorithm here inside of what we call response, and I'm using air quotes, right? Operational order-based planning. So it's a rules-based, priority-driven algorithm that can do segmented demand. So you could chop up certain customer segments, like these are my A customers and these are my B customers, and then I want to do forecast next, etc. So we allow for segmentation during the planning run in this prioritization technique. Okay. We also support some what-if analysis. So we have different versions that you could do. We have scenarios, and we actually even have a simulation of we call it the big deal scenario, where a customer calls up and you can say, all right, this is a sales order that's coming in. Can I take this? Can I make it? What's the impact if this thing happens? And you get to see that on the existing plan. Also, we have a root cause analysis. I don't want to steal all the thunder from the demo, but there's this via gating factor, which tells you if there's a problem, where is that problem in the network? Because we can go all the way from a customer end item all the way to a supplier for something that we purchased as part of the bill of material. Okay. One other really important thing as part of the output of this, and you'll see this in my next two slides here, is the third bullet point. We can generate allocations for an ATP process, for live ATP, whether it be GATP, regular good old ATP in ERP, or the new AATP inside of S4HANA. So we can provide those allocations for that, and they also can act as a constraint during our planning run as well. Okay, so let me take you through the different processes that we are enabling. All right, and you'll see as I go to the next three slides that the jobs and algorithms and the runs that we have to support these processes. Okay, so first one, starting at the top level, is a supply and allocations planning process. We create our supply plan, and that supply plan is planned orders, purchase requisitions, stock transfer requisitions, but we can also create these allocations as saying this is a constrained view of what my supply plan is to meet the demands. Maybe I can't make all of it. I can adjust these allocations, but then they can be passed downstream. The next process that we support is what we kind of call response planning. And this is also adjusting, adopting, recreating that supply plan based upon that prioritization. So we take into consideration forecast and forecast consumption here. But we also do one really important thing as an input to the process: allocations and other supply chain constraints, which I'll explain on the next slide. But we can create order reconfirmations as part of this process. So if I put this in old lingo terms, so to speak, we're combining the CTM run, that's like prioritization, and backorder processing from GATP into one planning run. Before they were segregated, right? We would do a supply plan, and then we would go do live online checks via GATP, or we would do a backorder processing. So that is happening together in one event, one planning algorithm. Okay, this is a big difference compared to what we had done prior. And then the subsequent process, third one, is we can satisfy some deployment planning capabilities. So we can adjust some of these supply proposals. We can create deployed stock transfer requisitions for ATD quantities. That's the available to deploy. So similar, you can define what it is you want to count as on hand. So I want to count stock and I want to count production orders, but I don't want to count planned orders. And then we can deploy that stock to meet the demands through the supply chain. This, of course, works very well and tightly integrated through, and we're not going to go into the integration in detail today, through SDI, Smart Data Integration, with orders and master data going back and forth between both ECC and S4HANA via an ABAP add-on. We, of course, can integrate to other ERP systems via some different techniques, but it's an ABAP add-on that sits on the ERP side that allows the transfer of data between the two systems. Okay, so a picture is worth 1,000 words. So these next 3 slides I'll go over quickly, but it's important to understand kind of the process flow here for that. So this supply and allocations process flow, again, the top one. And a question that I get sometimes is, do I have to run all 3 of these? And the answer is no. It depends on what your business case is. If you want to create allocations, you need to run this. If allocations aren't important to you, you can just do the confirmation run. And if you don't want to reconfirm sales orders as part of that run, you don't have to send them back. Right? You can just do it for a normal supply planning technique. And if you want to run deployment, that can be a subsequent follow-on process. So it's not necessary that you do all 3. It can be a mix and match depending on what your business needs are. But if we work from left to right here, we see that we take into consideration these rules, and we'll go over more of this in the demo. We have demand prioritization, supply sourcing by priorities. We take demands as a forecast into this process, and we also take some supply constraints. So they can be material constraints, capacity constraints, or supplier commits, and you'll see what that means. It's basically saying a supplier can give us so much. All right, so we can get an output of this. This orange box here is the brains of the algorithm. We can do some what-if analysis, and we generate 2 buckets of things, right? We generate a supply proposals, as I mentioned before, those 3 elements, and they can go back to ERP. And I left this generic on purpose because, again, ECC S4HANA integrated. And we generate allocations, right? And those can be passed downstream, again, generic to ATP for live order promising. You see this dotted line here, and that's saying these allocations that we created, you can see here, is optionally used during the confirmation run, okay? So now if I move to the next process flow, we're talking about this response planning. That was the middle process we supported in the system. It's called a confirmation run. Okay, same type thing, rules. We have prioritization. You could switch these up if you want. There's nothing telling you can't. And there's the allocations as an input. It's a time series key figure that acts as a constraint or a cap. Okay, so all of this, if you think about it, is every time we put a constraint on, whether it be an allocation or a supplier commit here or a material or a resource constraint, it's just making it more constrained, and the system has to work to figure out what's the best answer for this. So it may go down a path here and say, oh, I wish I could get this, but I'm all out of capacity, so now I have to go to a secondary resource within that plant. If that plant's completely out of capacity, I have to go to a secondary plant, right? So that's the process by which all these constraints play. The demands come in as before with a forecast, but this time sales orders with consumption. Everything here to the right is the same from planning, logic, and scenario and what if. The supply proposals are the same as we talked about before, can be adjusted, modified, deleted, recreated. But what is unique here, again, is the sales order commits, and we call that a confirmation. So if there's a request date on a sales order, we can give back the material availability date, right? We're not going to change what the request was. Maybe it was the 15th, but we can't do it till the 17th because of whatever reason. And the gating factor will tell us why that is. All right, so we process that, and they go to ERP. Okay, so finally then, from a deployment perspective, this is the third process here, similar to what many folks have done in the past from a deployment. This is a pull-based deployment. We have the same priority logic in here initially as part of our deployment capability. What's unique about this is now it's kind of the plant's perspective, right? It's saying, all right, what do I owe downstream? I owe a certain amount to DC1 for what reason? This because it's a sales order that's out there. So what's unique about this is the plant's perspective, it's not blind to why it's owing it. We have full pegging throughout the network and through the bill of material. So if there's a sales order that's out here at a warehouse 3 levels downstream, we know that that might have the highest priority if it's ranked that way, that we owe it for that reason, and he's going to get satisfied first, right? So this is what's interesting about the pegging. Prior to this, for those of you back in the day of APO, we knew we had a deployment capability, but it was always just knowing the quantity that it owed, but it didn't know why, because it didn't have the pegging. And this is where this is a key differentiator, all right? So we have those rules. You can adjust the rules again. You can leave them the same. It's another run within the system called a deployment run. And it also can do reconfirmations of the sales orders as well during this distribution process if you want to, and again with with what if simulation capabilities. Okay, so in summary, again, not to steal the thunder of the demo that we're about to see here, but just to kind of give you a preview of that, these are the categorizations of some of the benefits here, capabilities and strengths that we have in operational planning. So we can do this root cause analysis, right? We can do rough cut as tactical. We have a gating factor on here. We create that supply plan. It can tell us where we have some problems. We actually have an analysis here. If there's a situation where one demand isn't met, that we can show the competing demands of why one is getting ranked over the other. We can show our constrained forecast view based upon the output of that plan. We have version capabilities, as I mentioned, from a simulation scenario. We can include these simulative orders. We have this on the fly and persistent scenarios, and we can do analysis of those as well. We're going to go over this in more detail, but it is really important to understand the prioritization rules. This is the brain of the algorithm. How you define this rule, which is just a name and a holder, and it has these segments in there, and then the segment has this thing called a condition. And that's how you define the prioritization rankings, and then you can move them around from top to bottom. That is determining the way the demand is being satisfied. Okay, it's really important that that's the driver of the whole supply plan. Okay, and then finally here, some of the constraints and consumption strategies that we have. We can do allocation consumptions, as I mentioned. We have the constraints for material, production, supplier commits, and we can do forecast. Today, the forecast consumption is done within a period. So it's bucket-based consumption, and you can select day or week as part of the consumption profile. Okay, so with that, without further ado, let's pass it over here to Deep, and he's going to take us through the demo. Thank you.
Hello everyone, this is Deep. I will take you through the IBP showcase. First, let's review the supply chain network that we are using. As you can see in the screen, we are selling 2 finished goods, laptop A and laptop B, to 3 customers. Each laptop has unique components like CPU, board, etc., as well as a common component which is memory. Now, the BOM relationship for memory is that we need 2 units of memory to make 1 unit of laptop. The BOM relationship for other components is 1:1. Supplier 2 delivers memory parts in vendor hub 71. It takes 3 days to ship from vendor hub location to the plants. Additionally, plant needs 1 day to assemble components into laptops, and plant to DC transportation time is 2 days. This adds to a total of 3 plus 1 plus 2 or 6 days of lead time from availability of memory parts in vendor hub to laptops being available in distribution centers to deliver against sales orders. Let me also walk you through the set of sales orders we have to showcase demand prioritization. Let me highlight some flavors in the sales order set. We have orders for both laptops from both distribution centers across all 3 customers. We have 2 orders, 391 and 395, with requested date already in the past. These back orders indicate some revenue is at risk, so shipping these back orders is a high priority for us. IBP handles partially shipped orders as well. Order 368 has only 400 units still open from the 500 units requested. This tells me that we have already shipped 100 units. Now, IBP also handles customer or order specific requirements regarding late or partial shipments through the confirmation mode field on the order. Confirmation mode comes in 4 flavors: full or partial shipment, requested date only, or any date. We have orders with all 4 flavors. Later on, I will show you how confirmation mode combines with other constraints like product allocation to play a role in sales order confirmations. Let me now show you how IBP can flexibly prioritize demands. You are looking at the Fiori HTML5 web-based interface of SAP IBP. Each tile represents an app that performs a specific function. Let me start with the rules for demand prioritization app. We can define multiple rules to prioritize demands differently using this app. So let's examine order-based planning OBP rule 1, which we would like to use as the default rule throughout this showcase. Back orders are top priority and hence are included in the first segment. So now here you can see that within each rule there are multiple segments. Segments are to define a condition to select a subset of demands and a set of sort criteria to then sort these subset of demands. So for example, this particular segment for back orders has different sort attributes as well to further segment the demands. We define back orders as demand element with type VC for sales orders for which the requested date is before today. Now, sort criteria below will make sure that there is a further prioritization and ranking among all the back orders. We sort by requested date ascending. So back orders with earliest requested dates are given the higher priority. In a situation where we have multiple back orders on the same requested date in the past, we have another sort criteria in delivery priority to further segregate and prioritize orders. Now let's continue to see segment 2. Segment 2 are for our strategic customers 01 and orders that are shipped from DC02 to this customer. Similarly, segment 3 is also for our customer 01 but for orders shipped from DC03 to this customer. We catch all other sales orders in our segment 4 and sort them by requested date. And these sales orders are for all our other customers, example customer 02 and customer 03. So similar to the segments 2, 3, 4, segments 5, 6 and 7 are intended for forecast from DC 2, 3 and 1 respectively, irrespective of customers. So over here our MRP type is PR, which stands for forecast, and we have given the highest priority to location DC02, then it's DC03 and then it's DC01. We always put a catch-all segment at the end, which makes sure any demand which were not selected into the higher priority segments is still included in the planning run. This basically makes sure that all demand elements are considered. So as we see, each rule can have multiple segments. Segments are sequenced, resulting in a complete demand data set across forecasts and orders being prioritized and force ranked down to the individual order items. You have seen the sales order set that we are using in this showcase. We also have a set of forecasts that I have entered previously. So now let's see how OBP rule 1 prioritizes this set of demands. Let me take you through another Fiori app called View Demands by Priority. let's select our version and rule, which is OBP rule 1 in this case, to start prioritizing our demand. So here, as you can see, that our back orders, or the ones that has a requested date before today, are given the highest priority. Then comes orders from strategic customer CUS01, service from DC2. Then comes orders from CUS1, service from DC3, and then all our sales orders. Further, if you see, our forecasts are also being prioritized, with DC2 forecast given higher priority over DC3 forecast, which are in turn given a higher priority over DC1 forecast. This is just one particular example of how to prioritize orders and forecasts in IBP. IBP demand prioritization engine is pretty flexible to accommodate a wide variety of business requirements. I will create a rule from scratch to both highlight the flexibility as well as ease of use. Let's create a new rule, OBP rule number 2. Now over here, let's do away with the customer location based prioritization concepts of rule 1 and segment sales orders directly by delivery priority. So I'll click on new segment, say rule number 2, segment 1. So the first segment is for sales orders. Now I'll further add sort attributes, and the first sort attribute I'll add is delivery priority. We have 3 delivery priorities: priority 1, 2 and 3. Delivery priority 1 are the sort of rush orders that are most strategic for a variety of reasons and must be serviced first. Priority 2 are high priority orders which roughly maps to high volume customers, and priority 3 which covers all our sales orders. So now I have sorted by delivery priority first, and then further I'll sort by requested date. Now I create the next segment, which is for forecast. Over here, the only sort attribute I add is the requested date. And the third segment is our catch-all segment. You can just add it from the existing segments and save this rule. Let me now take you through the view demands by priority app. So here you can freely switch rules to prioritize your demand set differently. This can be done in base version or in an alternative version as well. So I'll select my new rule that I created and start prioritizing. Here we are doing everything in the base version, but demand or supply data from ERP as well as planning results can be freely copied to other planning versions for the entire set of product location combinations or a subset as well. This would enable tremendous flexibility to evaluate the impact to order confirmations and hence customer service levels. Measures like on time, in full, etc. with different prioritization schema against the same statement of supply. So now that our demands are prioritized, we see that the highest priority are the sales orders with delivery priority 1, and they are further sorted by requested dates. Then comes delivery priority 2 and then 3. So if you look at the next segment, which is for forecast, we do not have any location or customer specific priority for those. It's just based on requested date. So the forecast on 1st March are prioritized before the forecast on 2nd March. Hope this helps you understand how IBP deals with demand prioritization. Let us move on to understand how prioritized demand forecasts can be constrained based on component supply, manufacturing capacity, lead times, etc. Remember one thing, that constrained forecast run does not factor in any sales orders. Now let's see an example of this using the Excel UI. IBP enables access to order-based planning data through both the web UI as well as the planner-friendly Microsoft Excel. So let us log into our Excel, select the planning area which we want. We can define standard views for planners, which are referred to as templates. So this is the template that I have created, but planners can easily edit this template by going to this edit view. Over here, I have used daily time granularity, but I could easily switch to weekly or higher granularities with this flexible Excel view definition. Similarly, I can also change my planning level, and I can choose the level at which I want to see the data. Which master data objects to see the data for, and what data I am interested in viewing or editing. So over here, let's say in the forecast and allocations, I'm just interested in viewing the unconstrained and constrained forecast and not the allocation, since right now I'm just running the constrained forecast run. I'll deselect the other key figures. I can also select my own filter, and now my planning view is refreshed with the new key figures. So now I have loaded forecast of 100 units daily for laptop A in DC01. For laptop B, I have loaded 250 units daily in DC02 as the unconstrained forecast, while DC03 needs 150 units daily. This equals a total of 250 plus 150 plus 100, or 500 units of finished goods daily. You will recall that from our default prioritization rule 1, that forecast priority order is DC02 is given the first priority, then DC03, and then DC01. But now at this point, I have not introduced any constraints in my network. So now when I run the constraint forecast run without any constraints, so now after refreshing our planning view, we are able to see that the constrained forecast and the unconstrained forecast are the same. So now let's introduce a component supply constraint. Given that we have a total of 500 finished goods demand daily, this translates to a requirement of 1000 memory parts, given the 1:2 ratio of laptop to memory component. Net unconstrained component level requirement can be published to suppliers using SAP Ariba. Supplier response to this request can be factored back into IBP as a supplier constraint. In this showcase, we'll focus from the point when this constraint response from supplier is available digitally in IBP through Ariba. Let's say in our case, the supplier can only commit to providing 700 memory components daily against an unconstrained demand of 1000 memory parts daily. This means that we can produce a maximum of 350 laptops at any given day across laptops A and B across both the plants FA01 and FA02 combined. Now, to make this interesting, we have also modeled laptop stock in both DC and the plant. We also have a firm production order of 90 units on 6th March for laptop A. Let's see how IBP handles the supplier constraint against a prioritized set of forecast demands. Let's evaluate the results using the constraint forecast key figure. We'll see that the highest priority forecast from DC2 has been fully met. The entire 250 units is being met. The next priority forecast from DC03 is partially satisfied till memory components parts runs out, and the lowest priority forecast on DC1 is not satisfied at all. Both time phase netting against firm supply elements and component level constraints are also factored into this planning. So if you look at the initial stock, DC1 has 100 units of laptop A, which is being satisfied on 3rd March. Factory 2 has 200 units of laptop B in stock. 150 units that you see for first couple of time periods is because of that. Let's take a look at this in the system. Now that I have a supply constraint of 700 units, let me rerun the constraint forecast run. Now that the job has finished, we see that laptop A has constraint forecast only during certain time periods. If you remember that fixed production order of 90 units for laptop A, that is the one that is causing a constraint forecast in DC1 on 9th March. And for the first couple of period, DC3 has an unconstrained forecast equal to the constraint forecast, but after that the constraint forecast reduces based on our supplier constraints. Now that we understand how component level upstream supplier constraints are factored in planning, let us switch the focus inwards and model a capacity constraint in one of our plants. Resource A2 has a daily capacity to assemble a maximum of 480 laptops. In our model, resource A2 in plant FA02 only makes laptop B, while resource A1 in a different plant FA01 makes laptop A. Let's say that this resource A2 that makes laptop B is an aggregated model of several assembly cells in the plant, and some of these cells are not functioning for a specific period due to labor issues. Let's model this by lowering the capacity from 480 units per day to just 200 units per day. Now, if we execute a constraint forecast run with this reduced capacity definition, we see that the lower priority forecast for laptop A, which were being shorted before because of supplier constraints, are now being fully satisfied because now there are no supplier constraints. But when it comes to laptop B, only 200 units can be made, which go on to fulfill the demand for DC02 customer 01. For the first few days, the constraint forecast is 250 because of initial stock netting. Otherwise, from 8th March onwards, it's just 200. And for DC03, the constraint forecast is 0 throughout because of capacity constraints, and since this is a lower priority forecast, the one above is given higher priority and this is left unfulfilled. Let's have a look at this in the system. If we change the available capacity over here to 200, and now we rerun the constraint forecast run. we see that our lower priority forecast, the one for DC3, are not fulfilled then, and they are fulfilled at a later date when the capacity constraints go away. Similarly, even over here on 17th March, what it is trying to do is it is trying to fulfill the unfulfilled forecast, because the open forecast is 250 but the constraint is just 200. It is trying to fulfill the remaining forecast on 17th of March. Now that we have seen how internal manufacturing constraints can be modeled, let's move on to see the effect of lead time constraints. If you recall, the network lead time from memory component in vendor hub 71 to finished product in distribution center is 6 days. Note that the memory supplier has sent their commit from 27th February onwards in this case, and our forecast start from 3rd March. This gives us an effective lead time of only 4 days, 27, 28, 1st and 2nd, to move memory component stock from vendor hub, assemble laptops and plants, and ship to distribution centers. We know we need 6 days of lead time. Hence, the demands for 3rd and 4th March will experience a lead time constraint. We now see that DC3 does not have a constraint forecast of 100 units for the first few days, which was earlier the case. In this particular situation, this was because earlier we had provided enough lead time of 6 days. Now we provide a lead time of just 4 days. So what the constraint forecast run is trying to do is to satisfy the backlog of the highest priority forecast, the one at DC2, in the first few days by having a higher constraint forecast in the next few days, as it cannot meet the unconstrained forecast on 4th of March because of insufficient lead time. So over here, if you see, the constraint forecast quantities are higher than the unconstrained to satisfy this backlog. So let's have a look at it in the system. If we change the supplier constraint to 0 for these 2 days, 25th and 26th February, and rerun the constraint forecast run, we see that the constraint forecast is higher for the first couple of periods starting from 5th March to 8th March for DC2, as it is trying to satisfy the backlog on 4th March. So as you can see, a variety of constraints can be considered simultaneously against prioritized demand forecast to see projected service levels by customer, by product, by location, even before firm sales orders are received. Let us now bring in sales orders and see how sales orders are confirmed by executing a confirmation run. First of all, we should note that we are running the next particular operators based on the first scenario wherein our supplier constraint was 700 and we had sufficient lead time. So now we have added the supplier constraint of 700 back on 25th and 26th so that we have sufficient lead time, and refresh our planning view. Before running the confirmation run, we also have an optional step to copy the constraint forecast to a customer product location level allocation plan by using this copy operator. So these allocations, they can act as additional constraints to ensure limited supply of laptops is not all given to the top priority customers. There's something remaining for lower priority customers as well. Allocations can be defined at any levels like customer group, sales region, etc. But we will highlight this concept with customer level allocations. Now your allocations can also be different from your constraint forecast. Although you would want to respect the total product location level supply as the pool from which you generate customer level allocation. But over here, for example, let me change the allocation for laptop A DC1 to 150 and 100 units on 6th and 7th March respectively. Now that we have an allocation plan, we are ready to bring in sales orders as we execute a confirmation run. Confirmation run combines demand prioritization, supply planning, and backorder processing concepts in a single powerful run to minimize disconnects, where orders come in way different from forecast and supply plans based on forecast do not reflect a robust supply picture from which to generate order confirmations. A detailed order network in terms of pegging across the network and through the bill of material levels is generated along with the identification of gating factors after we run the confirmation run. For confirmation run, allocations act as additional constraints on top of other constraints like component upstream supply constraints, the internal manufacturing constraints, and the lead time constraints. So now let us run our confirmation run. Now that the job is finished and we see some confirmed sales orders, let us go to the View Confirmations app. This app can also report on order confirmations and help us understand issues in terms of orders confirmed late or not at all. Here we can also apply the sorting criteria to sort the things freely. So for example, I would like to sort by confirmation percentage and ascending so that I can see all the unconfirmed orders first. Another important thing to note here is that the sorting applied here is independent of how demands are prioritized, which enables options to sort all unconfirmed orders to the top of the report. So now first, let us have a look at this particular order, order number 367. We see that it has not been confirmed. If you go to the right and you look at the confirmation mode of the order, you see that the confirmation mode is a very stringent one, full delivery on requested date. So if entire 200 units is not available on requested date, the order will remain unconfirmed. Over here, you can further click on the order to view the gating factors. So here you see that the requested quantity is 200, confirmed quantity is 0. You can go to the order network. Here you see the gating factor that the product allocation quantity has been exceeded by 50 units. This order number 367 is for laptop A and customer 2. So over here we see that the product allocation available is only 150, but since the requested order is 200, none of it is confirmed. Let us similarly observe order number 406 for customer 3. This order is also unconfirmed. Now, if I click on this order number, I will see all the competing sales orders. So as a response planner, I can see that order number 368 from customer 1 is directly competing with order number 406 because both their requested date is 6th March itself only. Further, you see that the requested quantity is 125 and the gating factor shows that no allocation has been provided because the exceeded quantity is also 125. So now you will recall that from our OBP rule 1 that our customer 1 is strategic customer and it is provided the highest priority. So customer 3 has no allocation. But now let's say we do not want to ignore customer 3 altogether and we want to try and satisfy this particular sales order. So what I'll do is I'll provide an allocation of 125 units to customer 3 across 2 days, and in turn take that allocation off from customer 1. So I changed the allocation to 175 and 200 from 75 from 250 and 250, and gave 75 of it to customer 3 on 6th March and 50 on 7th March. Now we expect the entire order of 125 units for customer 3 to be confirmed. Let's try and have a look at it by rerunning the confirmation run. So on rerunning the confirmation run, we see that only 75 units of it is confirmed and not the entire 125. We do not see any confirmation on the next day. So let us have a look at our view confirmations app. So here we see that order 406, only 75 units of it is confirmed, and 50 units remains unconfirmed. And it still shows product allocation as a gating factor. So this is because if you look at the confirmation mode of this order, it's full or partial delivery on requested date. Partial delivery is allowed, but late delivery isn't allowed. So since only 75 units were available on the same date, only 75 units got confirmed out of the 125 units that were requested. Now further, if you see that for order number 368, which was an order of 400, it has been confirmed over 3 days instead of 2 now. Here, the confirmation mode of this order is full or partial delivery. So again, coming back to the View Confirmations app, as a response planner, I have the option to download this entire information in Excel for further analysis and reporting on metrics like on time, in full, average delay, and so on. Furthermore, I can also sort all these sales orders based on revenue um, at risk, and process the key exceptions in baseline versions or as a what if scenario as well. Now, let's examine how manufacturing capacity constraints can be modeled or simulated for impact to order confirmation. For example, you can model an emergency maintenance request which will drive a plant shutdown and see how it will impact order confirmations by modeling the capacity loss and rerunning the confirmation run. Let's say I reduce the capacity to 0 for these 3 days. Now let me rerun my confirmation run. So now here I see that the plant is being run on its full capacity for the next few days to compensate for the lost capacity because of an emergency shutdown. Let's also look at the View Confirmations app. And look at the demands for laptop B, whose plant was shut down. So I'll group by material number. My supply chain is not taking a lot of impact because of the shutdown. So here I see that still most of my orders are being confirmed. Some of them are delayed, but I'm okay overall besides the on time in full delivery sales orders. So my supply chain won't take that big of a hit. Now, if you would like to model a worst case scenario, you can also model an extended delay in getting the plant back up and see the impact of a 3-day shutdown stretching to 3 weeks. Now I'll refresh the view confirmations app. And over here now I can see that none of my sales orders are being confirmed. And if I further click on these sales orders, I see resource overload as the gating factor. Now, this kind of risk modeling and OTIF impact analysis can be done prior to agreeing to the emergency maintenance request by clearly understanding the revenue at risk against a range of supply shortage scenarios. So I could do this in my what if simulation version and or my baseline version if that situation comes to pass. Just like manufacturing constraints, we can also model transportation or procurement constraints by using these adjusted key figures. I can also flat out override the plan output like plan distribution receipts instead of adjusting input capacity parameters. This is useful if the planner wants to model a specific delivery constraint without having to engineer the inputs. So I can just provide the constraint by providing it in the adjusted key figures, like in this case adjusted distribution receipts. Let's say I provide a value of 50 for the next 1 week in this case, for how much uh, of the product laptop B can move from plant 02 to distribution center DC02 from 3rd March to 10th March. Now let me rerun my confirmation run. After this run has been completed, I can see my adjusted quantity gating factor over here in the view confirmations app. So for example, if you look at this particular order number 358, there has been an adjusted quantity gating factor. And if I further click on order network, I will see that the adjusted quantity exceeded is a gating factor for me right now. Let's understand the day in life of a response planner. Let's say sales reaches out with a potential large order, but we need to make sure that it can be shipped by the requested date without significantly impacting other existing orders. Let me show you how a planner can simulate both the big order as well as additional supplies or additional shifts in the plant without impacting the baseline version. Let's go into the simulate sales order application. So this sales order is for laptop B, location DC2, customer 1. The requested quantity is 5000 units on 14th March. And this is a very high priority order. So let us start our simulation run. Now that our simulation run is complete, we see that only 78% of the orders can be completed, that too not on the requested date. Some of it is confirmed at a later date. And also if you look at the impact, there are 2 other orders coming to this particular location material combination on 15th March which are left unconfirmed. So if you see, the confirmed percentage closes down to 0 for these orders. Let us open this in view projected stock application. Let us view our projected stock. So if you look at laptop B DC2, you see that our projected stock becomes negative once once the date nears the date of our order and our negative projected stock. So now we see our projected stock becoming negative around the requested date of this sales order. So now let us create a new receipt for memory which had a supplier constraint of only 700 units. I'll create a new receipt of 10,000 units on 7th March because my order date is 14th March. Now automatically a new simulation run starts. Once the simulation run is completed, we can open this view in the view confirmations application to see how our confirmation quantities are changing. So over here we see that our confirmed quantity has increased to 4,300 eaches or 86%, but still a couple of orders that were there on 15th March are unconfirmed. Let us first analyze this, our simulated sales order. So I still understand that since this is a large order, I will require extra capacity. So now that I want to simulate extra capacity without impacting the baseline version, I'll save this as a scenario. I'll give it a name, big order simulation. Now that I've saved it as a scenario, I'll go to my Excel view and simulate the impact of 2 extra shifts in our big order simulation scenario. Let's say I provide 2 extra shifts starting 7th March. Now that I have adjusted the capacity, let me rerun the simulation. So now I see that the entire order is being confirmed, but only 4,300 units are being confirmed on the requested date and the remaining 700 units are being confirmed at a later date. Let me also open this in View Confirmation app to see the impact on other orders. So over here I see that 3 of the sales orders are being impacted and not being confirmed because of this large order, and this order is being partially confirmed at the requested date and partially confirmed at a later date. Note that since all this is in the simulation mode as of now, none of the things in the base version are being impacted. Now I can communicate this result to other business users by sending this particular scenario to them, and if they agree upon this, then this scenario can be promoted to the baseline version, at which point the other sales orders will get impacted in the baseline version as well. As a part of typical day in life of a planner, you can also visit the View Gating Factors app to see issues by the gating factor. Now, you use this application to view the constraints that affect order fulfillment. With the View Gating Factors app, you get an overview of the constraints that are preventing you from fulfilling an order on time. For example, insufficient lead time, product allocation, or resource overload. We can also check the impact of gating factors on sales orders and forecasts in the order network. So for example, over here we can see that order number 403 has a gating factor of product allocation, hence it cannot be fulfilled. So you can click on this, go to analyze demand, and in this order network you see these gating factors and you can resolve the bottlenecks. Using the concept of detailed pegging, you can use this app to analyze 2 aspects of your supply chain. The first part is the supply usage. In this tab, you can directly trace the pegging relationship of individual receipts on any level of supply chain to their primary demands. In doing so, you can see, for instance, whether important primary demands are pegged to a safe supply source. Similarly, in the resource usage tab, you can see the resources that are occupied to produce, for example, parts that will be used to build laptops and the primary demand these laptops will cover. Since this lets you see whether the production resource is occupied to cover an important primary demand, you can react and free up production resources to fulfill primary demands of higher priority if necessary. So now in both these tabs, you can just select one of the entries and choose to analyze the demand. So over here, I can just click on Analyze Demand to see further information on the order, such as the order network items. I can also view all these order network items as a graphical view by choosing to display selected items as a graphical view. So here I can see all my network items in a graphical view. This application Analyze Supply Usage can be quite useful if you would like to understand how your constrained finished goods stocks in DC or production orders in plants are being pegged to ensure that your relatively secure supply is pegged to the high priority orders. This data can be seen in the web UI, or you can also now view it directly in the Excel UI. So with this IBP 1802 version, new planning levels and key figures have been introduced, which enable the response planner to see memory level purchase order and immediately proceed to see which finished good level sales orders are pegged to it. Now let us have a look at how we can analyze supply usage in Excel. So we have some particular set of key figures like the last five: total receipt used by demand, distribution receipt used by demand, and so on. These set of key figures allows us to analyze supply usage in Excel. Now over here I have included a filter for a material number memory, because if you remember, memory is the one that had a supplier constraint. So I want to see to which particular demand element is my supply of memory being pegged to, and I have also included a filter for demand type equals sales orders. So now if you have a look at this view, you will see at vendor hub 71 the total receipts are 700, and now out of those 700, 350 of them are used to manufacture laptop B for customer 1 at DC2. Then 200 of them are used to manufacture laptop B at DC3 for customer 1, and the remaining 150 are used to manufacture laptop B at DC2 for customer 3. So this way we can see how our supply of memory is pegged to three different demand elements for this particular time bucket. And the number 350 plus 200 plus 150 adds up to 700. But now if you look at 27th February, you see that the receipts are 700, but the distribution receipt used by demand is just 320 plus 200, that is 520. This is because we have put in a filter for sales orders. The remaining 180 units would be pegged against forecasts. Now I'm going to take you through the deployment process. Deployment enables us to distribute available supply to demands. For example, we can distribute stock from our plants to downstream distribution centers. Now let's take a look at the available to deploy profiles. If we see in the first profile, OBP deployment 1, we deem only production orders and stock in factory to be worthy of being considered for deployment. Note that planned orders are not included as valid candidates for deployment in this case. Now we can define multiple ATD profiles or available to deploy profiles, and also run what if scenarios based on including versus excluding planned orders from the scope of deployment. In the analyze supply usage, if I look at the production order and click on analyze demand, I see that it is a stock transfer requisition right now. There's a stock transfer requisition right now, and the production order is pegged to an open forecast. Similarly, if in my analyze supply usage, I look at stock that's present at factory 02 and analyze the demand, I see that it is pegged against an open forecast, and a part of it is fulfilled from a stock and other part of it is fulfilled from a planned order. So there's a stock transfer requisition, as well as a planned order is created, because the stock we have in hand is 200 units but the open forecast is 250 units. So requisition of 50 units needs to be created, which is shown over here. Now let's run the deployment run with OBP deployment profile 1, which only allows us to deploy stock and production orders. So I'm running using available to deploy profile OBP deployment 1. Now that this job is finished, let us analyze our supply usage for the production order. Now I see that a deployment requisition is created against an open forecast. Since this is a production order, it is turned into a deployment requisition. Let us try and do the same thing for the stock. Now here we see that the open forecast only creates a stock transfer requisition and not a deployment requisition, even though we have tick marked stock in the available to deploy profile. This is because of the fact that a part of open forecast is fulfilled by planned orders and a part of it is fulfilled by stock. So the open forecast does not convert the stock into a deployment requisition. Now, if after the first deployment run, we realize that our entire truckload cannot be fulfilled with only production orders and stocks, and we also want to include planned orders, we can maintain a different available to deploy profile. For this profile, OBP deployment 2 has all the supply elements including stock, production orders as well as planned orders. Now let's run the deployment run with this profile. Now I'm running the deployment run with the deployment profile OBP deployment 2. Now that this job has finished, let us check our pegged supply elements in the analyze supply usage. If we look at the production order, we see a deployment requisition, which is what we expected, as a production order is a part of our ATD profile. Now let us also have a look at the stock we had in factory 2. Here now we see that the open forecast created a deployment requisition instead of a stock transfer requisition, because since planned orders are also a part of our ATD profile now, deployment requisitions are created for planned orders as well. We can view all the deployment result in the Excel UI as well. So for example, over here we see distribution demand created from factory 1 to DC 1 for laptop A on 7th March of 90 units, which is our production order. Now these deployment results can be extracted and sent to ERP for execution or for further transport load building in a transport management solution as well. I know I have covered a lot of ground quickly. I would like to now pass it back to Eric, who will take you through the IBP order-based planning roadmap.
Excellent. Okay, thank you. So I was furiously trying to answer those questions there as Deep was providing the demo, and I think I got to most of them. A lot of the questions that came up were around the roadmap. So I'm going to cover that right now. We have, hopefully everybody's familiar with the roadmap that we published for cloud-based solutions. Okay, so first and foremost, we have a rolling three quarters. The first column is the most recent innovation, and then the next 3 quarters that are planned. So, and I'm going to get to the product direction, which is a subsequent slide. This is a preliminary one, which is the 1802 version. And I say that because it has not been officially published yet, even though we released our 1802 release. And there is, oh, I meant to mention, there is a way on the website to get this, right? So all of you should hopefully know this link, and then it changes. So I have to go out there every once in a while myself and find out how it looks. Now, if you just filter on the word integrated or search on that, you'll see it come up right here. Right now, it's the 1711 roadmap, unless they updated it within the last 2 days. Anyhow, so if I come back to this, we cover both tactical supply planning, which is time series synonymous, as well as order-based planning or operational based planning here. Today's focus, I'm going to talk just about the order-based side of things because that's the focus of the call. All right, so we've, and maybe some of you came on to the 1802 What's New webinar that we had about a week and a half ago, where one of our colleagues in the product team, Andrew Boyle, went through this. So we have this analyze supply usage. We actually now have the ability to analyze resources on that as well. We can do some of the supply pegging in Excel. We have some of the pegging information via Fiori apps, and now we can also see some of that pegging information via Excel as well. And then we did some enhancements around the best practice for order-based planning. In 1805, let's look forward-looking here. We have some big topics coming. So integration. So some support for integration from order-based stuff to the analytics perspective. A frozen horizon, which is, many of you are probably familiar. It says there's a period of time, and maybe it's 14 days, let's say, where I can't do anything. So this frozen horizon could be both for planned production as well as distribution. So before, in the world of APO, we had a stock transfer horizon, it was called, and then we had a manufacturing horizon. So this is same concept, but it can be used for both planned in-house as well as purchase recs and stock transfers. We have our first release of order-based LP optimization coming. We're going to have the ability to do some pegging as an output of that and some of the analysis of that pegging. We also have basic fair share. This fair share capability is part of the planning runs using the prioritization technique. Okay, so we call it kind of fair share with demand slices. I won't go into the details here, but this is not just for deployment. This is broader than that, but it's specific to the priority-based run. Okay, so what's really important about this optimizer, to go back to that in a second, is that's another type algorithm. Okay, so where today in time series-based planning, we had an unconstrained heuristic and an LP optimizer, we had a priority-based heuristic on the order side. Now we will also include, for its first release, the optimization technique for order-based planning. Okay. We have some version-specific master data, so that way you can change the data inside of the tool. And then we're starting down the process here to include order-based planning into the unified planning area, IBP1. It's, in this release, just a guideline and a how-to guide. It's a build-on-your-own type thing. It's not coming out of the box. Okay, so if I move to 1808, this was a couple questions here tied in with this integration and multiple ERP systems that I answered. So we have right now only one planning area that you can use for order-based planning. We're going to expand that to be able to define multiple planning areas. Okay, and this will tie in, as you can see here. I'll jump a little to the right here on integration in 1811. Right now, since we have one planning area, we have the ability really to just link one ERP backend system to this. There's some techniques that you could do if it's different data to combine it into one file to bring it in, but for most points, it's just one-to-one. So once that happens here, we'll be able to integrate separate integration source. So you could be like ERP1 could go to planning area 1, ERP2 could go to planning area 2, okay? And then they could be differentiated that way. So these two kind of tie together, and there was a lot of questions on that during the demo. Next up, this is planning strategy in terms of how it's doing this pegging. Right now, it's trying to peg to the closest supply. We can try to do it so that it'll peg to the preferred supply, which is one that is available now instead of one that's just closest to it as a technique. Component lead time offset. This is the ability to say during the manufacturing process when you're creating a planned order, where should my components be? You might be running something for a week. Right now, the components are all required at the start, so that might not be the best case. You want to spread those components out to be brought in, throughout the course of the manufacturing process if it's multi-staged. And then the supply chain network visualization chart. Many of you are probably familiar with this chart, and it was enhanced in, I think, the 1711 release. It's for time series-based planning now, so we'll have this on order data as well. Okay. I mentioned this one already about the integration. The other integration point is deployed STRs visible in S4. So today, when we create stock transfer requisition and we run deployment, it constrains it that one further level, and it becomes a deployed STR. Well, ECC doesn't understand deployed STRs, it only understands STRs. So really it's two entities on our side and one entity on the ERP side. So in S4, not being retrofitted to ECC, is the plan to enable those two data elements so we can sync them or link them one-to-one, okay? So that's important. Optimization. This is, again, going to be enhanced over time. First release here, I anticipate that this will continue being enhanced through the remainder of 2018 and 19 for that matter. This is a big topic, right? All of you that have worked with optimization in the past know that this is not a minor thing, right? This is a big entity. So we have some cost maintenance about how we're going to do costs and how to group them and make it a little bit more user-friendly from a cost maintenance perspective. Finally here, advanced forecast consumption. This came up in the Q&A as well. Right now, as I mentioned, we have bucket-based consumption. It's either day or week, and it's within the period. We want to do backwards, forwards. There may be some other techniques. We're doing some internal discussions on that and some co-innovations. So look out for that in 1811. Finally, multiple modes of transport. So this is being able to do on a lane, ship, rail, air, truck, etc. Right? So right now we have only one means of transport on the lane, so we have one duration. So this will enable us to do multiple means of transport with multiple durations. Okay, and then this is the product direction slide. For those of you that have looked at the roadmap in releases past, we always had that, and we actually had a lot of detail. I think the roadmap was like 120 or so odd pages. And then the last one that came out in 1711 was really thinned down, and it did not include the product direction, i.e. future slide anymore. So this next release of 1802, when it makes it to publication, I've been told it will have this product direction slide back in it, and we'll have limited details behind all those other releases. So instead of having 120 pages, I think it'll be closer to 40, but we'll at least have a little bit more behind the scenes, and this will come back, right? So I think the last version, 1711, was a little too thin. And I could take 30 minutes going through all these, but I want to just touch on some of the highlights here. As the Q&A came, quota arrangements is one that we got asked about. Support for characteristics right here, characteristics-based planning. I call that the umbrella. There's a lot of things under that. Shelf life planning is one of those things under it, attribute-based planning. So this is another one. Support for make-to-order and project segments. Right now we plan make-to-stock materials. We also are looking to enhance the integration. Right now it's a periodic-based integration. So product and location substitution is in the future direction here. This was part of the Q&A. And then allocation on components at aggregate levels. Right now you can define the level that you want it to be. So we're looking at increasing the functionality to be able to be hierarchical in nature in terms of how you used to be able to do some of that in GATP. And then if I come over here to the deployment planning side of things, we have deployment optimization as part of the roadmap item. Right now, again, recall that this is a prioritization-based deployment. It's not an LP. This is the LP version. Push deployment, I had mentioned right now it's pull-based, so it's whatever the demands are. If you want to have a surplus and you want to push those out, there's some workarounds now to do some changes in the quantities to kind of force the system to do that, but we want to make this automated. And then what we mean by load consolidation is similar to TLB functionality. This question comes up lots of times on how we're going to handle that. So that's the subsequent step to running deployment and doing some rough load consolidation. This is not defined yet. There's going to be some connectivity with both ERP and the potentially TM built in ERP. So this is something being worked on behind the scenes now. Keep an eye out for that. And then finally, the consideration of transportation and handling capacities, being able to use those as additional constraints during the planning runs. Okay, and then finally here, last couple bullet points, we have a desire to have an infinite supply planning heuristic, similar to what we have in time series, along with capacity leveling as a subsequent step on that. but the generation of orders behind it. And then many of you may have heard this DDMRP topic, which stands for demand-driven MRP. And this is something that we have in portions of IBP today. It's also, we have a partner solution. We also have something in S4. This is the supply side of that process. After you determine the buffer stocking levels and locations, how to come up with that replenishment plan. So this is something that's coming in the future, again, from our perspective on the IBP supply planning side of things. Okay, that takes us through the roadmap. Again, it's downloadable once it's formally published. Please do grab yourself a copy off the website. And we can take a look now at some of the Q&A.
Thanks, Eric. This is Ashutosh. Welcome, everyone. We just wanted to quickly wrap this up. I realize we are going a little bit over time, so thanks for staying in there. Just so you understand, response and supply, we've covered order-based planning, a lot of business processes today, some of the response management by exception factors that you see here. There are, as you can imagine, several advanced scenarios that we just can't cover in this time frame. How to set these things up, how to enhance the planning area, to bring in allocation or forecast consumption at different levels, how to bring in custom attributes, how to do lot sizing, and how delta planning works, and all of that. There are also miscellaneous topics around how the Ariba Business Network collaboration capability works to bring in supplier constraints, how you can set up analytics and alerts, and also very importantly, how the IBP integration in terms of smart data integration, STI, works with both ECC and S4. It also works with non-ERP systems, so there's a lot to learn here, obviously. And as Eric was talking about, there's also the time series planning side of it, which is the more S&OP horizon. And there is similarly supply heuristics and optimizer in terms of a lot of scenarios that you cover there, cross-plan production, co-production, and so on. And then there are advanced scenarios, right? So shelf life visibility, means of transport, subnetworks, the ability to run part of your supply chain and then provide more handshakes on the inner and outer edges of it, modeling aggregate constraints and minimum and maximums. We are getting some questions throughout Deep's demo on those lines. And obviously, there are other operators around supply chain data integrity checks and computing quotas and so on. There's obviously a different kind of integration for time series key figures in terms of CPI. It used to be called HCI before. The picture I'm trying to paint is we tried to cover a lot of ground today, but obviously there's so much more. If you're interested, what we do is we go through all of this content in detail, hands-on, deep dive 4-day or 5-day kind of workshops. So you're welcome to, if you want to participate in those workshops. There's one coming up on March 17. We will also be having a demand and inventory oriented bootcamp, and these are 5-day in-person training or workshops that we do in San Francisco Bay Area where GitaCloud is headquartered. So you're welcome to look at it as an online workshop over the weekends, or either on demand inventory in April or response and supply in June timeframe. And we've left the response and supply bootcamp in June precisely because of all the excitement around 1805 release. We want to make sure we are able to bring in and showcase the order-based optimization and some of the other capabilities. And there's a full events calendar, right? We do S&OP and other things as well. So when we send this deck out, you will be able to click on these things and go to the right places. For folks who are interested in IBP and want to learn on their own schedule, GitaCloud also has a learning platform where you can look at video recordings of past IBP workshops and content we've created. There's a YouTube channel out there, insights on our website. So there's a lot of content that we continuously work on to produce for the ecosystem's benefit. So we invite you to come into all of that. We have also, on the order-based planning side, just in the last couple of months here, ran 2 large POCs for 2 large customers and taken a lot of order-based planning requirements and model them. So if you're interested in order-based planning, you'd like to understand more how this works, I invite you to connect with us, reach out to us through email or phone, or there's also the website where you can enter a request form. We'll reach out to you and we will be able to help you both with your data and your requirements, and in a couple of weeks show you how order-based planning can be used. So I will take a pause at this point and let's just open the floor. I'll give it back to Guinter, see if the group has any questions.
So let me just start by complimenting Eric and team by answering more than 70 questions that came in. And I don't see a whole lot unanswered. There's one that I would like to pick out that is about the allocations. The question is, with regards to allocations at material, plant, and market level, is there a functionality to define the level at which the allocations are made?
Yeah, so yes, and I'll tie this into the roadmap. So you can define the level at which you want to do the allocations. You could do it by like product, location, customer as an example, or location, customer, product, DC, etc. What is interesting about this, though, is once you define that level, it's there today, set at one stage. What I think you saw on the roadmap there is being able to have that level have multiple tiers, because a lot of times people want to say, I want to look at it in a certain region if it's available. If it's not a region level, then maybe I can restrict it down to a location level and etc., and maybe to a product level or product group. So that's what's coming on the roadmap. But yes, today you can define the allocation, consumption, and level at the level you define it at.
Great. And I think you answered a couple others that I had summaries from a couple questions. There's one more. Is order-based planning included in the S&OP license?
Okay, so no, the license for this is for IBP for response and supply. So the S&OP license actually gets you everything that's included in S&OP, but from an algorithm standpoint, the unconstrained time series heuristic. On the response and supply license, you get the, as it stands today, the time series based optimization, and you get the prioritization based, order-based algorithm. And as you saw in 1805, we will also have the optimizer LP on order data model as well to generate those order supply elements, planned order, stock transfers, and purchase recs.
Great. Well, then I'd like to go to the last question. I'd like to thank Nikhil for his question. His question is, thank you for the wonderful presentation. And you're welcome, Nikhil. We really appreciate it. Ash, you want any closing remarks?
I just appreciate everyone's time. I know we took you through 90 minutes and it's a lot, and we wanted to give you a very detailed deep dive on order-based planning. So there is an exit survey that will launch after you exit the webinar. So we would request you to give us some feedback, just how we are doing, your interest in future such webinars, so we can make sure we are doing all the right things here. And thank you for your time again. Thank you, Eric. Thank you, Günther, and everyone else who contributed.
Thanks, everybody. This concludes the webinar.